Crime rates are a major public safety issue, and murder cases are among the most serious things. Selangor's growing population makes it important to understand the link between total crimes and murder cases. This study examines how the total numbers of reported crimes relates to the number of murders over time. A quadratic model is used because it can show more complex patterns compared to a simpler linear model. Crime data is arranged into matrix form, and row echelon form is applied using Maple to find accurate model coefficients. The best fit curve method helps to identify clear patterns between overall crime level and murder incidents in Selangor. The findings can improve understanding of crime trends and support better strategies to enhance public safety.
In this part, we want to find the best quadratic curve that fits our crime data. From the 10 equation, we form an augmented matrix. The first 3 columns come from the coefficients of A, B, and C in the model quadratic model. The last column is the Y value, the number of murder crimes. We will now use the reduced row echelon form to solve for A, B, and C. Our goal is to make all the interiors below this leading one become 0. First, we focus on the first column to make all below row 1 0. To do this, we subtract row 1 from every other row. So, after the operation, the first column now has 1 on top and all 0 below. Next, we focus on second column to make row 2 leading 1. So, we divide row 2 with the value on that position. We need to do the same thing to make all below column 2, row 2, 0. We can just plus each of the row with row 2 to make all 0. After simplify column 1 and 2, next we focus on column 3. We need to divide row 3 with the same value on that position to make its leading coefficient become 1. And to make it easier, the below row 0. So we do the same thing as we do in column 1 and column 2 to make each row in below row 3 0. Next, we have 3 leading 1 in each column, then we focus on next column, which is column 4. We need to divide with that value to make it 1. So we got the leading 1 by reduced row echelon form and need to decide whether it is consistent system or inconsistent system. So here the final matrix, and we can decide that this system is inconsistent because we have the row that 0 is equal to 1, lead to false segment.
By using normal system, we have to apply identity, which is A transpose AX equal to A transpose B. Firstly, list out matrices for A transpose A and B. Next, times A transpose with A, then we get 3 by 3 matrices. Then we find A transpose B, we get 3 by 1 matrices. We also have to check whether A has unique or many solution by finding the determinant of A transpose A. By using scientific calculator, go to matrix mode and insert the matrices of A transpose A to find the determinant, then we will get the answer. Since the answer is not equal to 0, therefore A has unique solution. Then we substitute the matrices in the identity of normal system, then the answer will be like this.
From the equation we obtained before, we transform it into augmented matrix form. Then we times row 1 with 1 over 10 like in the slide. Next, from the matrix before, we will focus on row 2 and row 3 to get leading 1 in the first column. We plus row 2 with negative 45291 with row 1, and for row 3 we plus it with negative 227452329 times row 1. Then we obtain leading 1 in the first column, first row, and 0 below the leading 1. After that, we will focus to find the second leading 1, which is in column 2. So, we multiply row 2 with 1 over 2232486.9. Then we will get the second leading 1. By using reduced row echelon form method, we need to make sure above and below leading 1 to be 0. So we plus row 1 with negative 4529.1 times row 2, and for row 3, we need to multiply negative 2.13587904 times 10 power of 11 and plus it with row 3. Then we can get below and above leading 1 are 0. Next, we focus on row 3 to get leading 1. So we times row 3 with 1 over 2.693758665 times 10 power of 13. So we already have 3 leading 1. Lastly, just like before, we need to make the matrix in RREF form. So we need to make above leading 1 are 0. We plus row 1 with row 3 multiply with 2058587.87. And for row 2, we need to plus it with negative 9567.226967 multiply row 2. So, for every parameter has a leading 1, which is the solution is unique. Then we substitute the a, b and c value in the equation y equals to a plus bx plus cx squared. Therefore, we can get the equation value which is y equals to 26.6242 plus with 0.01202x minus with 7.2943 times 10 power of negative 7x squared.
I will explain maple calculation of best quadratic curve by. Firstly, to make maple understand our needs, we have to restart with linear algebra and with plots. Next, we have to define our variables x and y. After that, we have to design and display matrix A. To design matrix AB, we have to multiply matrix A and matrix B. After getting the answer, we need to conduct reduced row echelon form of AB to check either the matrix is consistent or not. This, as we can see on the fourth row, shows the matrix is inconsistent. Since the matrix is inconsistent, we need to use normal system, which is A transpose A is equal to A transpose B. Firstly, we need to transpose A, and there is the answer. Second, multiply the A transpose with A to get ADA. Next, to know the type of solution of the matrix, we need to find the value of determinant A. So, we run the command, and this shows determinant A is not equal to 0. Therefore, A has a unique solution. We need to proceed with A transpose multiply with B. Lastly, we have to fulfill our equation and make it call as matrix M. By substitute A transpose times A and A transpose times B, we get a 3 times 4 matrix from all the value that we get. To find the value of A, B, and C, we conduct a reduced row echelon form of matrix A and evolve the RREF to get a real value in point form. As we can see, these are the value of A, B, and C. Lastly, substitute the value of A, B, and C to design the quadratic equation. Y is equal to 26.62415248 plus 0.0160223815 minus 7.2943288735 times 10 power of negative 7 x squared. According to the equation, we design a graph. From the graph, the fitted quadratic curve indicates that the dependent variable increases as the independent variable increases, but the rate of increase gradually declines. Despite the presence of random deviations, the model provides a reasonably good representation of the observed pattern.
So we done the first part. With all the information, we can find the error vector. We use formula E equals to B minus AX. We need to find the value AX first, and then we do B minus with AX and the result as shown. To find error vector using maple, we need to do command as answer and put the value A, B and C. And next, use command error Y minus A multiply answer. So we get the result same as manual calculation.
To find the magnitude by using manual calculation, we have to square root the sum of square error vector. To find magnitude by using maple, we have to write a command which is mag_err equal to norm in bracket err, 2, and we get the same answer as manual calculation.
So, we can conclude that a quadratic model was used to study the relationship between total reported crimes and murder cases in Selangor. The final equation is y is equals to 26.6242 plus 0.016202x minus with 7.2943 times 10 negative 7 x squared. It shows that the trend is not linear, meaning the murder cases do not increase proportionally with total crimes. Using the normal equation it can help to obtain valid solution after the initial matrix was inconsistent. The error magnitude is 26.4225. It indicates that the model fits the data reasonably well. Overall, the quadratic model effectively represents the crime-murder relationship, and adding more data or variable in the future that could improve accuracy.